Chapter 7 Applications of Differential Calculus. Example number 7.1. Example 7.1. The question is, for the function f of x is equal to x square, x belongs to closed interval 0 to compute the average rate of changes in the subintervals 0 to 0.5, 0 to 0.5 to 1, 1 to 1.5, 1.5 to 2, all are closed intervals, and the instantaneous rate of changes at the points x is equal to 0.5, 1, 1.5, 2. So in this question, the given function is f of x is equal to x square. So we need to compute the average rate of changes. Average rate of changes in the subintervals, 4 subintervals. And the second one is instantaneous rate of changes at the points. Here also 4 points. X takes 0.5, x takes 1, and x takes 1.5, also 2. First, we write what are given and what we need to find. So given our f of x is equal to x square. For write f of x is equal to x square, and this x belongs to closed interval 0, 2. We need to find, so number 1 is average rate of changes in the subintervals (0 to 0.5) closed interval and 0.5 to 1. So 1 to 1.5, also 1.5 to 2. All the 4 intervals are closed intervals. And the division number 2, the second question is calculate instantaneous rate of change. Instantaneous rate of change. Changes at the points x is equal to 0.5, 1, 1.5 and 2. So solution. The formula for average rate of changes in the subinterval is, the formula is average rate of change in the interval is in the interval closed interval a comma b is f of b minus f of a by b minus a. This is the formula. This is the formula to calculate average rate of changes in the interval closed interval a comma b. This is equal to by our function f of x is equal to x square. F of x is equal to x square. So substitute here b square minus a square by b minus a. It is equal to, by the identity we get b minus a, b plus a by b minus a. The first term cancelled. Therefore, this term is equal to b plus a. Now give the answer for the question number 1 in the tabular form. So give the answer for the question number 1 in the tabular form. So first to form the tabular column. Average rate of changes in the interval. That is f of b minus f of a by b minus a. This is nothing, it is equal to b plus a. Here a, here b. So average rate of changes in the interval closed interval a comma b, that is equal to f of b minus f of a by b minus a. This is equal to b plus a, already calculated above. Therefore, by our question, our a is equal to 0, 0.5 and 0.5 to 1 and 1 to 1.5, 1.5 to 2. So b plus a, just add these two, that is equal to 0.5. 0.5 plus 1 is 1.5. 1 plus 1.5 is 2.5. 1.5 plus 2 is 3.5. This tabular column is the answer for the question number 1. For the question number 1, the answer is the tabular column. And for the division number 2, so we put one more tabular column for calculating instantaneous rate of changes. Instantaneous rate of change. This is equal to f dash of x. So instantaneous rate of change, that is dy by dx. Our question f of x, therefore first derivative is f dash of x. This is equal to, our f of x is equal to x square. Therefore f dash of x is equal to 2x. So here write 2x. So instantaneous rate of changes at the point 0.5, 1, 1.5, 2. So here x takes 0.5, 1, 1.5 and 2. So 2 into x. So 2 into 0.5 is 1. 2 into 1 is 2. 2 into 1.5 is 3. And 2 2s are 4. This tabular column is the answer for the division number 2. So number 1 calculated, number 2 also calculated. Therefore, the question number 7.1 is complete here. Is completed. So now example number 7.2. Example 7.2. The question is, the temperature T in Celsius in a long rod of length 10 meter insulated at both ends is a function of the length x is given by T is equal to x 10 minus x. Prove that the rate of change of temperature at the midpoint of the rod is 0. So in your question the given function is T is equal to x 10 minus x, and the proving result is the rate of change of temperature at the midpoint of the rod is 0. First write the given function. So first write the given function. So T is equal to x 10 minus x, and to prove rate of change of temperature, that meaning is dt by dx at the midpoint of the rod length is 10 meter, therefore the midpoint value is 5. So dt by dx at x is equal to 5 equal to 0. In our question, the given function is T is equal to x 10 minus x. To prove, so dt by dx at the point x is equal to 5 equal to 0. Here x takes the value 5 because our rod length is 10 meter. The midpoint means 10 by 2 is equal to 5. So start the solution. So our T is equal to x bracket 10 minus x. First just multiplied inside it, we get 10x minus x square. That is equal to 10x minus x square. Now we calculate dt by dx. So first derivative of t. So 10x derivative is 10, x square derivative is 2x. So now dt by dx with respect to the point x is equal to 5, this is equal to, just substitute x is equal to 5 in the previous line, that is dt by dx. So that is equal to 10 minus 2 into 5. This is equal to 10 minus 10, that is equal to 0. So the rate of change of temperature, that is dt by dx in the midpoint of the rod, that is x is equal to 5 equal to 0, that is proved. Hence proved. Therefore example number 7.2 over. Thank you.